So for those of you who were gone on Wednesday, we were working through problem number 10, showing how to use gas stoichiometry along with the ideal gas law. So I have question number 10 highlighted there. Ammonium sulfate, an important fertilizer, can be prepared by the reaction of ammonia with sulfuric acid according to the following balanced equation. So what they're asking us to do is calculate the volume of NH3 in liters needed at 20 degrees Celsius at 25 atmospheres to react with 150 kilograms of sulfuric acid, which is H2SO4. So because we're not at STP, then we have to be using the ideal gas law, which is, I'm going to switch over here, KB equals NRT. Let me try that again. Okay, so in the equation, we've been able to identify a few things like P equals 25.0 atmospheres. We were asked for V, and we want to find V. So that's the thing that we don't know. And there was no mention of the number of moles, so we're going to find that one out. R, we know, is 0.0821 liter atmospheres per mole Kelvin, and our temperature was 20 degrees Celsius, so we add that to 273, giving us 293 Kelvin. And so all that information is found in here. That's our 20 degrees Celsius. We added 273. We added 25 atmospheres. Our R value is always a constant. And then N is the one that we don't know. So what we have to do is be able to convert this 150 kilograms of H2SO4 into something that we can use, into the number of moles. So here's all of our information, but we don't know how many moles of NH3 we're going to end up getting if we have 150 kilograms of sulfuric acid. So that's where our stoichiometry comes in. So we have to convert this. So here's what we have to do is get out of kilograms of H2SO4 and into moles of H2SO4. Now, there's two ways that you can do this. You can either do it in a two-step process where you have 1 kilogram of H2SO4 is equal to 1,000 grams of H2SO4. And then from there, we can convert from grams into moles. So that's totally fine to do. So we're going to have grams of H2SO4 and moles of H2SO4. So we have to use our mole ratio. We know that that's always 1. And then we have to figure out our number of grams by looking at our periodic table. So we take 2 hydrogens. So each hydrogen has a mass of approximately 1. Each sulfur has a mass of approximately 32. And each oxygen has a mass of approximately 16. So we take our 16 times 4, our 1 times 2, and then we add all those numbers together, and that gives us about 98. Because we're only using 2 significant figures up here, we don't really need to worry about how many significant figures we have further down. Okay, so now that we're in moles of sulfuric acid, we can now convert from moles of sulfuric acid into what we need, which is our moles of NH3. So where we end up getting that number is we have to go back to our balanced equation. So we look at NH3 has a coefficient of 2. H2SO4 has no coefficient, so that is really a coefficient of 1. So we can plug those numbers right in here. So 2 and 1, and then we can solve. So we multiply everything across the top, multiply everything across the bottom, and we end up with something close to 3,069 moles of NH3. And so there's two ways that you can do this. The alternative is to take these numbers right here, and we can make that into one step. And essentially what that does is we're going to cancel this step with this step to combine them together in order to make a single step, which would be kilograms of H2SO4 and moles of H2SO4. Even though we know it's still 1 mole, but instead of kilograms, since a kilogram is 1,000 times bigger than a gram, we can just convert this by moving our decimal place 3 places. So we're going to have to add in a 0 here, and that will end up being 0.098 kilograms. So instead of doing 2 steps, you could just do that as 1. It's really up to you, whatever your preference is. But now that we have our 3,061 moles, we have the information that we need. Get rid of some of this. Now we're back to where we started. And so we have our answer that we're going to be using. So this is our number of moles, which is going to equal our N, which will be 3,061. And then that would be moles. So now that we have that, we can rearrange our PV equals nRT into something that is useful for us. We want to find V. So V equals nRT divided by P. Then we just plug in our numbers. So we have 3,061 moles. We have our R value of 0.0821 liter atmospheres over mole Kelvin, and our temperature of 293 Kelvin, all over our pressure, which was 25 atmospheres. So we double check to make sure we set it all up right. Our volume should be in liters. So to check that, our moles cancel, our Kelvin cancels, our atmospheres cancel, leaving us with liters. And so when we solve all of this, we just plug that into our calculator. And that gives us 2,945 liters. However, go back and remember that in this step, we only had 2 significant figures. So that means that in our answer, we can also only have 2 significant figures. So that'll end up being 2,900 liters of NH3. Right, so that kind of walks us through that type of problem, using our problem solving skills and manipulating our data so that we can use it in something that is meaningful to us. And if you have questions, let me know, and we can talk about it tomorrow. Have a good day.